All right, so we're going to kind of get away from graphing. So as far as like y equals mx plus b and that stuff, we're not going to see that again until the final. All right, so on your guided notes, this part, I'm just going to read to you. When we get to the part with a circle and then there's like a number symbol, we'll fill that in. But first, I just want to explain to you what that word is. So a monomial can be several different things. It can be a constant, which is just a number. Right? So if you have the number 6, it's a number, but you can call it a monomial. Okay? It's another name for it. Or you can have a letter. A letter is also called a monomial. Okay? So,
why is it called a monomial?
just a different name for it. That's all. Just a different name. Or you can take numbers and letters, and what does product mean? Well, add would be a sum. Multiply. So you can take a number and a letter and multiply them together, and that's also a monomial. Okay? These are all examples of monomials. The only thing you can't do with monomials is add and subtract. If you start putting plus and minus signs in, it is not a monomial anymore. So, is that a monomial?
Yeah.
Yeah, it's just a number. Is that a monomial?
Yeah.
Yep, it's a letter. How about a number times a letter?
No. Yes. Yes.
Product, right? That's a monomial. So these are all examples of monomials. Sometimes you have exponents too. And we'll talk about that, but that doesn't change it. It's still a monomial. So when you think monomial, think numbers, letters, or when you multiply numbers and letters together. Okay? Just no adding, no subtracting. This is not a monomial because it has an addition sign. Okay? We'll talk, actually I don't know if we ever talk more about that. But. Okay, so on your notes, okay, you should have that little diagram. Okay, and there's two things there to fill in. So when you write a number that has an exponent, like this part right here, this part right here, the exponent is the number that's up higher. Okay, that's an exponent. It's the number that's up higher. The base is the thing that is lower. Okay, so in this thing that I circled right here, what's the base? The base is x, and in this case it's a letter. What's the exponent in what I circled? 3. Okay. So the base is x, the exponent is 3, and that's it. Okay. Exponent is always a number. The base could be a letter or a number. That's a monomial. It's a monomial that has a number for the base and it has a number for the exponent. Okay, both. Hey, any questions on those two terms? Exponent and base.
What goes in the circle?
What's that?
What goes in the
The
circle?
circle? Nothing right now. It's just that's what's circled is the base. So, you know, you could have x squared. X would be the thing that's like in the circle. It's the base. I don't. But if you want to sign out, you could go to that. Okay, anytime you want to multiply or divide monomials, what do you think you have to use for letters? Same letters or different letters?
Different.
Same.
Different?
Can I have a copy of the guided notes, Mr. Sure, thank you. Who Who said the same? Who thinks you can only combine things that have the same letters? Who thinks you can combine things that have different letters? How many people aren't sure? I don't know what the fourth option would be. But the bases have to be the same. Okay? So on the notes where it says to multiply and divide monomials.
You gotta write bases have to be the same.
So for example, you could take something like this and combine it with something like that. Why? The bases are the same.
Kind of like what we demonstrated, guys. It's similar to combining like terms. Right, you look and see if those bases are the same, but it's going to work a little differently.
Here's another example. That's a monomial. That's a monomial. What's the base on both of them? A. What's the exponent on the first one, just to make sure we can identify that? What's the exponent on the second one? 4. These have the same base, okay? But they have different exponents. That's okay. You can have different exponents. Bases have to be the same. Okay. What we're going to do is we're going to write this one out, okay, how to do it. And then I think you'll see a pattern, and we won't ever have to write it out again. There's a shortcut to multiply these two things together. What does it mean when I write A with a 3 up high? Like if you had to explain that to somebody that doesn't understand an exponent, what does that mean to do? Sai?
Multiply your number by the same number as many times as that number.
Yeah, the number, or it could be a letter. Exactly.
Well said.
So what does A to the 3rd power mean?
A times A times A.
Yep.
It means A times A times A. And what about A to the 4th power? Yeah.
A.
Now, if you read that off, you have A times A times A times 4 more of them. How many A's are there?
Oh.
7. So if you multiply A times itself 7 times, what's a short way to write that? A to the 7th power. So does anybody see a shortcut? Look at the exponent, that's the answer. And look at the 2 exponents we started with. Exactly. All you have to do is take the 2 numbers that you're given and add them. That's one of like 3 rules we're going to learn today.
Hey guys, another way for like the exponents, it's the base multiplied together as many times as the exponent is. So like A to the 3rd, right? It's A multiplied together 3 times. That's what it means. Sorry.
Okay, so let's try a few of those, but we're not going to write it out. Okay, I want you guys to use that pattern. When you have bases are the same, you take the 2 numbers and you add them up.
Now guys, you have to write out these you have space where it says the example, but you have to write the actual example up on your notes. On the front side. We haven't got all that stuff yet, no. There's a couple of bullets up there, guys. We haven't got to those yet. We're going to get to them after we do these.
All right. Example 1A. Are those bases the same? Yes. What's the base? R. What's the exponent on the first R?
7.
Okay. What about the second one?
Doesn't have 1.
It doesn't have one.
It's an invisible 1.
So it's like an invisible 1. Exactly. Actually, I think we wrote that. Okay. Whenever there's not a number written, pretend like it's a 1 and put it in if you want. Put in a 1. So now when we multiply these together, what's the base going to be? R. Okay, the base never changes. Only the exponent.
The base.
What would the base be? 8. It's going to be 8. Okay? We're going to write down this rule. I think that's the next thing that
Yeah.
we do.
And guys, for every number that you write, or every variable that you write, it's always to the power of 1. We just don't write it every time, right? It's just like when we have no sign to the left of a number, like if this says 7, we know that's what kind of a number. It's positive, right? We just know this is the way it is. It's just assumed that it's that way. Same thing of a number of variables written out with no exponent. We just assume it's to the power of 1. So if there's no exponent, it's a 1. Every time, not 0, it's 1. Marissa, question?
Yeah.
Oh, okay. Come over.
Okay, let's look at the next one. C squared times D squared. What's the base in the first one? How about the second one?
D.
Are they the same?
No.
No. So can you do anything with it? No. The only thing you could do is just write C squared, D squared. You can't, that cannot be simplified. Okay, different bases, can't do it. Now, if I had something like C squared, D squared, and then C cubed, there's something I could do here. I have something with a C, something else with a C. Those could be combined. Okay? The D doesn't have anything you can combine it with. Okay? So, any questions why this one you can't simplify? All right. How about this one? X to the 4th times y to the 6th. There's nothing you can do there. Most of the problems we give you are not going to be like that. Most of them you're going to have to do something. I'm going to give, I think the next one, yeah. Okay, how about 1D? Can that be simplified? Why? Because the bases are the same. So in the final answer, what's the base? Keep the base the same. What about the exponent? 5. If you multiply 2a's times 3, you'd have 5, and that's the exponent. Okay, so we just took 2 plus 3. In fact, if you want me to write it out how we did it, we did 2 plus 3. I normally just write the final answer, though, for a problem like that. Some problems we do, they're going to be multi-step. Probably, maybe later today, but more tomorrow and Thursday. We're going to have to do multiple steps. Okay, but these are pretty much one step. There's not a lot of work to show. 1e, m to the 4th times m to the 12th. That, how would you write it? M to, yeah, just say 2 to the 16. Yep, m to the 16. And that's it. Okay, when you write your answer, try to make sure that exponent looks definitely like an exponent. If you do something like this on the test, you know that, it's hard for me to tell if that's an exponent. So just make it very clear it's an exponent. Okay?
So guys, if we had those examples that we just did, right? If we had to put that into we had to give a rule, describe a rule for when we're multiplying exponents. Does anybody think they might know how we would describe that, what our rule might be when we multiply exponents? What do we do? Huh? You get the big thing. What do we call that? It might be a letter, it might be a number. What do we call that? The base, right? So Antonio said if we'll say the like terms, we could say about the bases, right? The bases have to be what? The bases have to be same. If the base is the same, what do we do with the exponents? Yeah, if the bases are the same, we're going to add the exponents. And basically, that's what we're saying right there. So on your notes, all right, you have where it says to multiply, not to raise powers, the first bullet, right, to multiply powers. You're going to write what's underlined, all right? With the same base, you add the exponents and keep the base the same. Add the exponents, keep the base.
And this is the first, I think there's 3 rules today.
I think so.
Product to a power, power to a power,
Yeah.
I think.
So if there's no parentheses or anything like that, guys, all right, we're just gonna see what we got for bases that are the same, keep the base, add the exponents, add those small numbers.
Okay, does everybody have that rule?
Almost.
And I don't think there's anything else. No, nothing there. All right, so we're going to try that rule, but we're going to try it on problems that have a few more parts in it. Okay, so we're going to try example. We'll come back to raise a power. We're going to go to the back of your notes now. We're going to go to the back. All right. You know what? We're going to do that one, but before we do 2A, let's do this one together. We have this times that. Are there any numbers in the first set of parentheses? Just a number by itself? Yep. Where? Which one? What's the number? Yep, -3. Are there any numbers in the second set of parentheses? What? 7. I circled those in the same color. Why do you think I did that? Because they're like terms. Exactly. What's after the -3? Okay, we have something with a C. Do we have something with a C in the second one? Yep. And we also have a term that's a D, another term that's a D. And what operation are we doing here? There's only one operation in that whole problem. Multiplication. -3 times C squared times D times 7 times C times D cubed. It's times. Everything is times. So if when you're multiplying, what you can do is think of like terms being next to each other. All I've done is I rearrange the order. I put the -3 and 7 next to each other, the C squared and the C, the D and the D cubed. And it's like you have 3 little problems to do. Okay, so that's how you can think of it in your head. If you want to write it that way, you can. If you don't want to, you don't have to. You can just look at the original problem and go right to the final answer.
You guys, one thing that I do, and sometimes when you're doing this stuff, it's hard because it's a whole bunch of information. And what we've done up to this point is kind of had everything like combined together. When we're doing this, all right, the whole numbers, the -3 and the 7, they're separate. Sometimes what I do is I draw lines to separate each thing, all right? The different variables with the exponents are also separate. So the variable with the exponent on top of it, that's separate too. So this C to the second is separate from that D. This C to the first, because there's no exponent there, is separate from the D to the third power. So sometimes what I do is I go through and I separate each thing. The numbers from the variables with the exponents. And sometimes we may get into stuff where these whole numbers have variables, right? The number or the variable with the exponent is always separate. The different variables are always separate. So you can think of it that way too.
All right, so can anyone tell me the answer to this first part? -3 times 7. Yep, -21. Remember, this is all multiplication. How about the next part? C to the what, Kyle? C to the third, good. And the last part, D to the fourth. And that's the answer. So it's kind of like what we did in example 1, except we had to combine like terms, not just with a single letter, but we had multiple letters. That's all. Okay. When we look at this one, yes?
I was just going to ask, so we multiply the regular things, but the small numbers, we just add them?
Right, when you multiply any exponents, any variables with the same base, add the exponents. Yep. Okay, is there a number in the first parenthesis here? Yep, what is it? It's -5. Is there a number in the second parenthesis? Well, it's kind of like invisible. It's an invisible 1. So when I write it, I like to think of it as having that invisible 1. Okay, let's multiply it. -5, -1. What do you get when you multiply those together? Well, it's a negative times a negative. +5. All right, so we took care of the numbers. Now, if you have the same letter written more than once, it's not simplified. The final answer should only have the x written one time and the z written one time. Okay? So I have an x here, I have an x here. Okay? What would I get when I combine my x's? Exactly. X to the third. Is there any questions on why it's to the third? Yeah, because we added it. 2 plus 1. Yep, it's 3. All right, so I'm just going to kind of check off things as we do them. What's the next letter in the first parenthesis? Y. I'm going to look. Are there any other y's to combine it with? No. Then it just gets copied down. You don't have to do anything with it. Okay, I'm going to keep looking. Is there anything I haven't checked off yet? Z to the third. Are there any other z's? No. So that is your final answer. Great. Any questions on that one? All right, why don't you guys try 2B? You could put parentheses around that too. It doesn't really make a difference. If you like to do it that way, you can, but it doesn't make a difference.
Like I think guys, you want to draw lines to it, separate, you can do that too.
All right, somebody raise your hand and tell me what you got for the number part, like the number that's in front of everything. Liam?
Which one?
The number, the very first thing.
Oh, well, there was no other A, so I just put 3A.
Even before we get to the letters. Marissa? -6. Yep. So if you want to separate it, Mr. Roy said, you have a 3 times -2. Everything here is multiplied. Okay? -6. Now we're going to look at the A's, and what Liam said was correct. There's an A here. There's no other A's anywhere. So there's nothing to combine it with. Copy it down. Next one is a B. Look through. Is there anything to combine with the B? Yes. B to the 4th and B cubed. So what would that give you?
B to the 7th.
Yep, B to the 7th. Now, any letters that are left I haven't looked at yet?
C.
C. The first one is C to what power?
1.
C to the 1st combined with a C to the 8th. C to the 9th. And that's it. Okay, you know it's simplified when you look at it. The letter A, how many?
Could I have your attention, please?
In that final answer, how many times is the letter A written? Just once, just right here, A to the 5th. The B, we only see it one time, and the C, it's only one time. If you ever had something like this as a final answer, it's not simplified. If you have two of the same letter written in 2 spots, those should be combined together. Like that. Okay? All right, so that was our first type. This rule, I think, did you guys already copy it?
Could I have your attention,
All right, next rule. This is the rule when we have something like this. We have a power, like a to the third power, but then we have another power. So this is when you have a power raised to another power. Okay? Any question on what that is? It's a power raised to another power. What's that? We're going to write the rule in a second. Okay? You're going to write to raise a power, and I'll show you what it is in a second. So, I want to simplify a cubed to the fourth. What is, yeah, let's see why. A cubed to the fourth. That means to take this, what I just circled, and multiply it how many times? 4 times. A cubed times a cubed times a cubed times a cubed. That's what a cubed to the fourth power means. Multiply a cubed 4 times. And now, this is a problem just like we had before. What would you do with all these 3's? Yeah, 3, 6, 9, and the last one would give you? 12. So, somebody already said it, but what do you think the shortcut is to get that number when you start with a 3 and a 4?
Multiply the 3.
You what?
Multiply the 3 and 4.
Yeah. Multiply the 3 and the 4. Okay, so the second rule for today, to raise a power to another power, you multiply the exponents. 3 times 4, that's how we get 12. And you keep the base the same. Okay, and there's going to be one more rule. We'll just squeeze it in somewhere. That has to do with a product to a power. We'll find it. Okay, so to raise a power to a power, multiply the exponents, keep the base the same. All right, so now we got a rule where we add exponents sometimes, and we also have a rule where we multiply exponents. We just have to keep those 2 rules straight. Okay, you guys ready for example 3A? We're still copying? Okay. Now, you don't have to write this out the way I showed you the first one 5 times. Just use the shortcut.
Yeah, use the rule we're just talking about.
It's a power to a power. Sabrina, when I do this out, what is the base? C. Just like we said, keep the base the same. And Natalie, what about my exponent? 10, and how did you get it? Yep, multiply the 2 exponents. And that's it. C to the 10. Now, some problems we do, I think example 4 maybe, it's going to have this rule and the last rule in the same problem. Okay, so right now we're just looking at this rule by itself.
Okay, you might have 2 sets of information. And then you have to do power to a power, and then you'll be able to combine them.
Okay, Derek, how about y cubed raised to the 10th?
Why the 3?
So, y 30?
Yeah, y to the 30th, yeah. Y to the 30th power.
If we didn't say it like that in my old school, we used to get points taken off.
I prefer you say y to the 30th. Just how did you say it?
So like if we didn't say like power at the end, we would get just like
Oh, y to the 30th power? You could, that's okay. If you say y to the 30th
That's why I don't
power,
take any points off you, if you say,
that's fine.
why the 30th?
Just don't say y30.
Yeah.
Y30 to me means this. That's Y30. Or this. Y30.
Hey, Antonio.
And,
Oh, did you just say that?
yeah.
Okay, so that one's pretty simple. Does anybody have any questions on a power to a power? In fact, I'm going to go like this. I want you to, let's try, this is, you don't have this on your sheet.
You guys, you don't have to worry about writing this, we're just gonna go over it.
Okay. What would I do first there? Yeah, think of like PEMDAS, you always deal with exponents first.
No, no, write this one. Figure this, okay.
What's x cubed to the 4th? What we just did there, that's the rule we just learned. Now, what do we do here? This is the first rule we learned. Now you add the 2 and the 14, 2 and the 12. Okay? So this is a problem that had both rules in it. Okay? Any questions on that? All right, last rule. So the last rule is when you take a product and raise it to the 3rd power, or 4th power, any power. It's when you have something in parentheses and you're raising it to a power. This is called a power of a product. So, can somebody tell me what that would mean to do? 2x cubed. How would you write that without the 3?
X to the third power, to the third power.
Yeah, so what's in the parentheses? 2x, and how many times do you do it? 3 times. Now, this is a problem just like we had before. Okay, you can split it up. You have a 2 times a 2 times a 2. You can't see my time signs anymore, but what's 2 times 2 times 2?
What's the base?
2x.
What's one of the bases?
Oh, it's 3, x to the 3rd, and then 8.
Okay, so I like that. You add x to the 1st times x to the 1st times x to the 1st. You had x to the 3rd.
And you would be 6 because you multiply all
I got 8.
And how,
2 times 2 is 4, and then 4 times 2 is 8.
so how many 2's are there? 3. So I heard some of you say 8. That's correct. But notice what we did. We cubed the 2 cubed, and we cubed the x cubed. So all you have to do is, it's kind of like distributive property, but you put it as an exponent. 2 to the 3rd, x to the 3rd. That's how you do it. Okay, so on, if you have room, you could put it above example 1A and 1B, right below the 3rd rule.
Yeah, that's what I was thinking, Mr. Hager. Guys, you only have to write what's typed. That's all you have to write, is what Mr. Hager will be typed out on that.
You can't read it?
I'll show you. I'm gonna go out.
Someone's at the door.
Really?
So to raise a product to a power, raise each individual factor to the power. Just write that on your
Basically what that
notes.
says is each thing inside the parentheses, each number or each variable needs to be raised to whatever power is on the outside of the parentheses. So Mags on your front side. Below this line, you squeeze that in.
No,
No, below, yeah.
So if I was going to do that one, what's going to happen to the 3? It's going to be raised to what power? And what's going to happen to the x? So again, you can kind of think of it as a distributive property, but you're putting the number as the exponent. 3 to the second, x to the second. Now, if this is small enough, we're going to have you do it out. What's 3 to the second? So what is 3 to the second power? 9. So on a problem like this, it's small enough you could do it out. If it was like 3 to the 10th power, that means 3 times 3 times 3, 10 times. That's kind of big, we wouldn't do it out. Okay, does everybody have this rule before we look at our last few examples? Yep, we're on example 4A. You want it? All right. You? No.
All right, guys, one thing here, if you're not, because you look on the inside of the parentheses and there's no exponents. There's no exponents written there, but what do we know that needs to be there? What does the negative 4 have and what does the C have? To what power? 1. You don't have to do this, but if it makes more sense for you, you can. You get something like this and there's no exponents, right? You can put a 1 and a 1. What's one of the terms inside the parentheses? What's one of the terms?
C.
Huh? C is 1. What's the other one?
-4.
-4. What I'm going to do is, I'm going to draw a line in between the two of them so I know that they're separate. All right? And what am I going to do with that 3 outside the parentheses? What am I going to do with that 3 outside the parentheses?
Add the other.
Careful. Watch it.
Multiply.
Multiply to what?
To the other exponent.
To this 1 and that 1, right? The 1 with the -4 and the 1 with the C. Right? I think of it almost like it's a backwards distributive property. But remember, you're only multiplying to the exponents, the little numbers. We're always keeping the bases. The bases are never going to change, ever. And the stuff we do this week. The bases will never change. The only thing that's going to change is the exponents. All right? So what's my -4 going to become? -4 to the...
Third power.
Remember, I'm multiplying now. I'm not adding anymore. Like I said, I think of it as backwards distributed. Negative, I want to multiply 3, all right? 3 times 1 and 3 times 1. 3 times 1 up here, 3 times 1 down there. All I'm doing is multiplying the little exponents. All right? So you want parentheses around both things?
Yeah, can you talk about that?
Okay. So we want to make sure we put parentheses around both things. All right? And then we're going to have C to the 3rd. Is that what you want, Mr. Hager?
Now, why is it really important you put parentheses around that -4?
So it doesn't look like it's connected to the tree.
Not because of what comes, even if the C wasn't there, I still want parentheses around that -4. How come?
So it doesn't look like -43?
No.
Yeah, so with this, when we have a number, and what Mr. Hager is going to show you guys is, if you put it in as -4, and your calculator as -4 with no exponents to the 3rd power, all right, you're going to get something different than what you should get. So you're going to make sure you put parentheses around it, all right? So Mr. Hager, you want to show them that?
Yeah, so watch what happens if you do -4 to the 3rd. Okay, you get that versus -4 to the 3rd. Well, what power is this? 3?
3rd, yeah.
Okay. In this case, what happened? Nothing. Came out the same. So like, well, why does it matter? Watch this. -4. Let's do to the 2nd. What did I get? 16. Let me do it without parentheses. Did I get the same thing that time? No. So if you want to be safe, always put parentheses around it.
On the numbers, right, Mr. Hager?
Yep, and
Right.
then, yeah.
So that, I mean, if you put parentheses around the C to the third, it's okay, but whenever you have a whole number, especially when it's negative, make sure you put parentheses around it. All right, it makes a big difference. It's a weird thing, guys, where, unless you know the rule, right? We have a negative base here, right? Is 3 an odd number or an even number? Odd, right? When I have a negative base, all right, and an odd exponent, my answer is always going to be negative. When I have a negative base and an even exponent, my answer is always going to come out as positive. That's the way it works. But we don't expect you guys to memorize that rule. And most of the time, Mr. You can correct me if I'm wrong, most of the time we're not even going to have them simplify this, are we? They're going to be able to leave it as that, or do you want them to simplify it?
That would be small enough, probably, yeah. I mean, if you simplify it and it's a number in the millions, then no.
Yeah.
But if it simplifies to a number less
Like
than
100?
100?
Yeah.
Yeah.
So if you simplify that, guys, it came out less than 100, you could do it. So we get, with this, based on that rule I just talked about, is that going to be positive or negative? I got a negative base, even odd exponent. Negative, right? It'll be negative 64, C to the third. I got that by simplifying this. So if you simplify and you get something less than 100, you get a whole number with an exponent, and you simplify it, and it's less than 100, then we'll have you guys do that. All right? But sometimes I might say in the directions to keep your answers in exponent form, this would be fine. If we asked you to keep your answers in exponent form, that would be fine. All right? But if you see, and if you, on a test on Friday, if it's a multiple choice, if you get something like that and you don't see it as one of the options, simplify this, and chances are you'll probably get that as the option. All right? This is one thing to keep in mind. Let's take a look at the next one. All right? First thing, is there anything inside the exponents I should write in myself? So I know.
1.
For what? For the x, right?
X to otherwise.
I want to put x to the 1 there. All right? How am I separating them? Where should what's one term inside the exponent? Inside the parentheses, rather. What's one term? Negative x, right? To the first, negative x to the first, doesn't matter. I'll draw a line right between there. All right? So now, I'm going to get negative x to the what? Negative x to the fourth, right? Again, power to a power, backwards distributive. I'm multiplying the little numbers, right? I'm multiplying the exponents. I'm not adding them now. As soon as I see parentheses and this at the end, I'm multiplying. If there's no parentheses, the parentheses are gone, that's when I'll combine the bases, right? But in this case, I'm just going to multiply them, all right? So I'll get negative x to the fourth. And what about my y? Y to the eighth. You want parentheses around this right here?
Yeah, and simplify it a little further, yeah. So guys, what do we need to do? Anytime we raise a negative quantity to a power.
Oh.
Because now, what's going to happen? Think about, it's a negative thing to the fourth power. So it means negative times negative times negative times negative. Right?
Remember, negative, we'll talk about this in the warm-up tomorrow too. Negative base, even exponent, answer comes out positive. Negative base, odd exponent comes out negative. Right? Because it's even, it's always going to match up. If I had negative x to the third, negative x times negative x times negative x. That's negative x to the third right there. All right? Negative x times negative x will give me that positive, but I still got to get that negative floating around that's what's gonna cause it to become negative. If I did it to the fifth, I could do 2 together. If I had it to the fifth, I'd still have that one floating around. Any negative base, odd exponent, negative result. Negative base, even exponent, right? My answer's gonna come out positive because it's balanced, all right? So we'll get x to the fourth, y to the eighth. And we'll talk about that rule a little bit more tomorrow with the negative base, depending on what the exponents are, all right? 4C, I'll go back up so you guys can see this one. 4C, all right. Anything inside the parentheses, I could write it myself, even though it's not written there. Anything inside the exponents, I could write, even though it's not written there. For the what, Marissa? For the D, right? Okay, good. What am I separating? How many terms do I have inside the parentheses? Maggie, how many terms do I have inside the parentheses? How many different things, huh? How many different things do I have inside there?
4.
Okay. Like numbers, letters. I have a 3, right?
Yeah.
That's one thing. I have a C to the second.
Yeah.
That's another thing. And I have the D, right? D, we wrote D to the first, or D, doesn't matter. 3 different things, right? Remember, the exponent and the variable and the exponent are a package deal. They're tied together. The variable and the exponent are a package deal. Same thing goes if there was a number, all right? A whole number with an exponent. They're a package deal. They're connected. Just like we always say, the sign to the left is attached to that number or that letter. Same thing here. The exponent to the right, like this 2, is to the right of the C. That's connected to the C. They're attached. All right? They're together. I could also put to the first power with that 3. What's 3 going to become when I simplify? What's the exponent for 3? Obviously 3 is going to stay, right? That's the base. The base never changes. 3 to the what? How do we get 3 to the 5? 5 times 1, right? Backwards distributive. Backwards distributive. All I'm doing is multiplying the little numbers, the exponents. How about, we know C is going to be there. We know that base is going to be there. We know D is going to be there too. C to the 10th, right? How'd you get it, Nene? 5 times 2. What is multiplying, right? Sorry. How about D? What do I mean for D?
D would be D5.
D5, how'd you get it?
I multiplied the D by the 5.
5 times 1, right? All we're doing is multiplying the exponents. Is there anything else I can do there? No, there's no, with this one, there's no negative bases. So we don't have to do that rule I just talked about. Here, I'm done, I'm fine, there's nothing else I can do. I'm perfect right here. All right? Have another one? All right, now we're going to get a combination of both things. We'll get a combination of both things we talked about, actually all 3 rules we talked about today. All right? Inside this first set of parentheses, how many terms do I have? How many terms do I have inside that first set of parentheses? 2. What are they?
4 and
Negative 4 and x. What can I put with the negative 4 and the x?
1.
I can put 1 to the first power with each. 1 here, 1 there. Let's do this right now. All right? When I do that, Aiden, what am I going to get? Negative 4 to the... Good. Remember, now, third, and Ashley just said it, parentheses. Where, Ashley? Around the negative 4, right? So we're dealing with a negative number. I'll put parentheses around that. Okay? We'll leave that for now. How about in my other set of parentheses? How many terms? What are they? 5 and x to the third, right? There's nothing here. I can put a 1. Trenton, can you tell me what I would get when I simplify that?
5.
Yep.
And parentheses.
Yeah, you can do parentheses if you wanted to. This is a whole number. Sure.
And
2
2.
to the second power, okay?
Yeah.
Yep.
And 3. 5
So the 5's done. What about the x?
Oh, yeah.
X to the,
X to the 30.
careful, 6.
Oh, 6.
Remember, I'm multiplying here, right? It's okay, buddy. X to the 6th. Okay, good. Now, I want to simplify those whole numbers right now. Let's simplify those whole numbers. All right? So make sure Mr. Ray's going to put it on his calculator, and he's going to make sure he puts parentheses. He's going to put parentheses -4 to the 3rd power. Now, on your calculator, if you're not sure, all right, the little exponent button looks like this. It's like a little carrot. Or like a little upside down V. That's what it looks like. All right? So, Mr. Hager just did it. We're going to get -64. Negative base, and an odd exponent gives us a negative result. X to the 3rd doesn't change. How about 5 to the 2nd power? Anybody know what that's going to be? 5 to the 2nd power, if I simplified it. 25. Because it means 5 times 5. So 5 to the 2nd power will be 25. If you're not sure, just put it in a calculator. And then x to the 6th. X to the 6th will stay. All right, what's one pair of things that I could multiply there?
-64
-64
and 25.
times 25, good, because they're just whole numbers, there's no exponents, all right? I can just multiply them. This is the one time that the bases would, I mean, they're not the same anyways, so we'll just multiply them like normal, right? We're gonna get -1600. So that takes care of the -64 times the 25, all right? What's the last thing I can do?
X to the 3rd and then times X to the 5th.
X to the 3rd, x to the 6th. I don't care so much right now about the exponent, but what am I gonna have to write as part of my answer? X, right? Why? It's the base, right? Keep the bases. What will the exponent be?
18.
No, we're not multiplying now. Huh? 9. KD, we're only gonna multiply when the exponent's on the outside of the parentheses. We wanna multiply it in. When it's like this, just keep the base and add the exponents. It's like a combination of what we've done. All right, as far as today goes, that's as tough as it gets, right there. That's as hard as it gets for today. Right? Now, all week, the stuff we covered today, we're still gonna have to know those rules, because tomorrow we're on to something different. But you're still gonna have to know power to a power. You're still gonna have to know how to multiply exponents with the same base. Still gonna need to know all those rules. All right? Homework tonight, 6.1. 6.1 is a big chapter. There's a lot of different stuff. All right, we're breaking it down into 3 parts. So the rest of the week is going to be all 6.1. We're just breaking it down into 3 parts because there's so much information. All right? Next, part 2 of the test will be on Friday. There'll be no take-home part, but you'll get a reference sheet to use on the test on Friday, just like normal. All right? It's only going to be on exponents. Graphing is done until the final. We're not doing any more as far as using y equals mx plus b to graph and systems and stuff like that. We're not doing that again until the final exam. That's done. All right? The stuff, the graphing, the shading, that's done. You're not responsible for that in the test on Friday. That's why we did it yesterday. Guys, remember, listen, you're only going to have 3 tests this quarter. The one on Friday will be the second of the 3 you're going to have. Then the last week of May will be our last week of new stuff. Then we're going to start getting into the final exam. All right? Progress reports for this quarter. Quarter 4, close on Friday. So if you have a test or something, or homework you want to get made up, you want to get it done by Friday. If not, it's going to show up on your progress report. If you don't make up a test. Now on Friday, if you don't get that part of the test done, Mr. Hager's probably going to put grades in. You might see when you get your progress report next Friday in shop, it'll say 0 for test not made up. That means you're not going to get a 0. That means that you just didn't finish the test from this upcoming Friday. Last thing, remember, you got a double shop week coming up. Next week and the week after. That means on Friday, which is May 5th, we're not going to see you guys again until May 22nd. That's your next academic Monday. That's your last academic week of new stuff. The end of that week, I think it's the 26th, will be your last test for the quarter. After that, we're getting ready for the final exam.